Space is vast and full of mysteries. It stretches beyond our imagination, filled with countless stars, planets, and phenomena that we are only beginning to understand. Some mysteries lie closer to home than we think. Our own solar system holds secrets that could change our understanding of life and the universe. Jupiter and Saturn are gas giants in our solar system. They both have numerous moons, each with unique characteristics. Europa orbits Jupiter, while Enceladus orbits Saturn. These moons are fascinating worlds of their own. These moons are very different from our own. Unlike our rocky and barren moon, Europa and Enceladus are covered in thick layers of ice. They are covered in ice, creating a stark and beautiful landscape that is both alien and intriguing. But under that ice, scientists believe there are vast oceans. These hidden oceans could be teeming with life, protected from the harsh conditions of space by their icy shells. NASA wants to explore these oceans. Why? Because they may hold the secret to life beyond Earth. Discovering life in these oceans would be a monumental breakthrough, because they may hold the secret to life beyond Earth. Microbial life has been found in extreme conditions on Earth, such as underwater thermal vents, suggesting that life could exist in similar environments elsewhere. This is no easy feat. Sending missions to these distant moons requires advanced technology and careful planning. It will be a long and difficult journey. The spacecraft will need to travel vast distances, enduring the challenges of deep space. The robots will travel millions of miles. They will be our eyes and ears, sending back valuable data from these distant worlds. They will face extreme temperatures and radiation. The conditions on these moons are harsh and unforgiving, but NASA is up for the challenge. The engineers and scientists are working tirelessly to overcome these obstacles. They are building special robots for the job. These robots are equipped with the latest technology to survive and operate in such extreme environments. These robots are designed to survive the harshest conditions. They are built to withstand the cold, radiation, and other challenges they will face. They are our brave explorers into the unknown. These missions will push the boundaries of our knowledge and bring us closer to answering the age-old question, are we alone in the universe? Europa and Enceladus are incredibly cold, with their surfaces blanketed in ice and snow. The surface temperature can drop to a bone-chilling minus 250 degrees Fahrenheit, making it one of the harshest environments imaginable. That's colder than anywhere on Earth, even more frigid than the coldest places in the Arctic or Antarctic. The robots must be able to function in these extreme temperatures, equipped with technology that allows them to operate where humans would instantly freeze. They also need to withstand intense radiation, which is another formidable challenge. Jupiter and Saturn emit a lot of radiation, creating a hazardous environment for any electronic equipment. This radiation can damage electronics, causing malfunctions or complete failures. The robots must be shielded from this radiation using advanced materials and designs to protect their sensitive components. But the challenges don't stop there. The environment is as physically demanding as it is hazardous. The surfaces of Europa and Enceladus are not smooth. They are rugged and uneven. They are covered in cracks and ridges, creating a treacherous landscape. The robots need to be able to navigate this treacherous terrain, moving over and around obstacles with precision. They may even need to drill through the ice to reach the oceans below, which could harbor signs of life. This requires special tools and equipment designed to operate in the harshest conditions. The robots are like high-tech mountain climbers, scaling icy mountains in space, pushing the boundaries of exploration and technology. These robots are not remotely controlled from Earth. They are designed to operate independently, far from human intervention. The distances are too vast. Communication delays can stretch from minutes to hours, making real-time control impossible. It would take too long for signals to travel back and forth. The speed of light, while fast, is not instantaneous over such immense distances. Instead, the robots need to be able to think for themselves. They must be equipped with the capability to make decisions without waiting for instructions from Earth. This is where artificial intelligence, or AI, comes in. AI provides the necessary computational power and decision-making ability. AI will allow these robots to make decisions on their own. They can assess situations and determine the best course of action. They will use AI to analyze their surroundings. Sensors and cameras feed data into the AI systems, which then interpret the information. They will use AI to avoid obstacles. Whether it's navigating around rocks or avoiding deep crevices, the robots must be adept at maneuvering. They will use AI to complete their mission objectives. From deploying scientific instruments to collecting samples, AI ensures precision and efficiency. Imagine a robot approaching a large crack in the ice. The terrain is unpredictable and challenging. It needs to decide whether to go around the crack or try to cross it. This decision is critical for the success of its mission. This is a decision a human would make. In the past, such decisions required human judgment and experience. But thanks to AI, the robot can make this decision too. It can evaluate the risks and choose the safest and most efficient path forward. Section 4. Practice makes perfect, even in space. Before sending the robots to Europa and Enceladus, NASA needs to make sure they work. They do this through rigorous testing. The robots are put through their paces in environments that simulate the conditions they will face in space. Imagine a giant sandbox filled with ice and rocks. This sandbox is like the surface of Europa or Enceladus. The robots are put in this sandbox and given tasks to complete. They have to drive over obstacles, they have to collect samples, they have to survive the extreme cold. If they fail, the engineers make adjustments and try again. It's like a tough space school for robots. Section 5. Are we alone? The search begins. The exploration of Europa and Enceladus is about more than just testing robots. It's about answering one of humanity's oldest questions. Are we alone in the universe? The oceans beneath the ice of these moons could hold the answer. If we find evidence of life on these moons, it would be one of the most significant discoveries in human history. It would mean that life is not unique to Earth. It would mean that the universe is teeming with possibilities. The robots we send to these icy worlds may be our eyes to a whole new world. They may help us unlock secrets we never thought possible.